this lesson, I'm going to introduce you to quadratic functions. I'm going over some key features as well as the different forms of quadratic functions. So what exactly is a quadratic function? Well, it is a type of nonlinear function, so it is not a line. It is actually a U-shaped graph called a parabola. And here we have an example of a quadratic function, or of a graph of the quadratic function. And this is the equation that goes along with this graph, y equals x squared. And this is actually called the parent function of quadratic functions. As we see here, it starts at the origin of 0, 0. Let's take a look at some key features of quadratic functions. The first key feature is called the vertex, and that is actually the highest or lowest point of the parabola. And we have here the vertex, the circle right here, and this is actually the highest point on this graph because the graph is facing downward. Next, we have the axis of symmetry, and this actually cuts the graph into two equal parts, and whatever ordered pair you have here, so the vertex here is at the ordered pair 0, 4. The axis of symmetry is actually the x value of the vertex. So the axis of symmetry in this case would be x equals 0. And the axis of symmetry is this dotted line right here. And note the axis of symmetry does not always have to be on the y-axis. It could be anywhere on the graph. It is a vertical line that crosses the x-axis. Next, we have our x-intercepts, also known as the zeros or the solutions, and these are the values of x where the function y equals 0. And here in green we have the x-intercepts, so we could see actually where the graph crosses the x-axis. So here the x-intercepts would be the ordered pair 2, 0 and -2, 0. And again, these are also called the solutions or the zeros. So when you get into actually solving quadratic functions, and when you're finding a solution, you're actually finding where the graph crosses the x-axis or the x-intercepts. And note, a quadratic function can have 0, 1, or 2 x-intercepts. So in this case, this particular graph has 2 x-intercepts or 2 solutions. Next, we have the y-intercept, and that's where the graph crosses the y-axis. And so just like you have the x-intercept where the graph crosses the x-axis, you have the y-intercept where the graph crosses the y-axis, and the y-intercept is actually right here. I'm trying to draw an arrow. Okay, this is actually a y. Okay, and it's crossing the y-axis here at 4. We have the maximum if the top of the graph, if the graph opens downward, we have a maximum. So in this case, this graph has a maximum because the graph opens downward, and the vertex will actually be the maximum of this graph. If the graph opens upward, then we will have a minimum. So the maximum is the highest point on the graph, the minimum is the lowest point on the graph, and it is the vertex. So remember, the vertex is the highest or the lowest point on the graph. So again, we have a maximum here because the graph opens downward, and this is the highest point on the graph. So we have different forms of quadratic functions. The first form we're going to take a look at is the standard form, and that's written in the form ax squared plus bx plus c, where a and b are coefficients, or the number in front of your variables, and c is a constant. A cannot equal 0, so it has to be more than 0. And c represents the y-intercept. Remember, the y-intercept is where that graph crosses the y-axis. So whatever number you have for c, that is where that graph crosses the y-axis. So here's an example of an equation, quadratic equation in standard form. So your A would be 2, your B would be 12, and your C would be -4, and C would actually be, or -4 would actually be your y-intercept where that graph crosses the y-axis. Next, we have vertex form. That's y equals a times x minus h squared plus k. And hk is the vertex. So as an example here, we have the problem, or the equation, y equals 2 times x plus 3 squared minus 22. And so the vertex would be -3, -22. Notice because we have a positive 3 here, and in my formula, or in the formula, we have a negative. So your vertex is going to always be the opposite of this sign here. So if you see a plus, your h would be negative. If you see a minus, your h would be positive. So the vertex, your h value is always the opposite sign, and it is actually the ordered pair. So it would be your x and y, or your minimum or maximum, or the highest or lowest point on your graph. And last, we have intercept form. Y equals a times x minus p times x minus q. P and q are your x-intercepts, and remember, x-intercepts are your solutions, or your zeros, or where your graph crosses the x-axis. So once again, remember when you start working out your equations, this is what you're looking for. You're looking for those solutions. If it's already in intercept form, you can see the solutions. And so I have an example here, y equals 2 times x plus 3 times x minus 1. So P and Q would be -3 and 1. And again, it is also the opposite. So since you have a negative in your formula, whatever number you see here, it will be the opposite. So if it's a plus, it would be a -3. If it's a minus, it would be a 1. And so if you were to graph this graph will cross the x-axis at -3 and 1. So let's analyze the letter A a little bit more, which is the coefficient of your x squared term, or the number in front of your x squared term, and how it relates to the vertex and the minimum or maximum. So now if A is negative, then that graph will open downward. And if the vertex, if the graph opens downward, then you will have the highest point on the graph, which would be called the maximum. So the vertex would be a maximum if A is negative. And here are some examples of graphs where A would be negative. Right here, we have maximums right here, here, and here. An example of an equation where A would be negative is right here. That would be a -2. So without graphing, you would know that that graph would face downward, and the vertex would actually be -1, -3. And we have another equation here. Our A is negative, so that graph would face down. And one thing we can discern from this -10 is the y-intercept. So that's just the added piece of just analyzing these equations. Next, we have if A is positive. So if A is negative, the graph opens down. So if A is positive, of course, that graph opens up. And so if the graph opens up, it is going to have a lowest point, or the vertex would be the lowest point, and it will have a minimum. Here are some examples here. So all of these, 1, 2, 3, would be minimums. And here are some examples of equations where your A is positive. We see here that 2 is positive. This 2 is also positive here, and this 3 is positive. So if your A is positive, your graph opens up and you have a minimum because you will have the lowest point on the graph. If your A is negative, you will have a maximum, which would be the highest point on the graph, because that graph will open downward. Alright, so I would like for you to take a look at these two equations, example 1 and example 2, and write out what the y-intercept would be, whether that graph opens up or down, and whether or not it would have a minimum or a maximum. So go ahead and pause the video and try these two examples on your own. So hopefully you got the answer correct, or the answers correct. Your y-intercept would be at 2, so the ordered pair would be 0, 2. The graph will open up because the a is positive, and that graph will have a minimum because that graph will open up like this, and then you will have a minimum. Number 2, your y-intercept is 0, 1. The graph opens down, right? And so that graph will, of course, have a maximum. So hope you got them correct. Let's take a look at more key features. The x-intercepts are here at -3 and +3. So the ordered pairs would be -3, 0 and 3, 0. Because remember, in every ordered pair you have an x and a y, and your x is always first. Your y-intercept is -9. You see it down here. This is where the graph crosses the y-axis. And so the ordered pair will be 0, -9. And do you remember how we find the y-intercept from an equation? Well, the y-intercept will actually be c from your equation. This is in standard form. We don't have an x term. Remember, this is standard form, ax squared plus bx plus c. But you don't have to have an x term. It is considered a quadratic function as long as you have an x squared term. So remember that from the parent function. So no x term, but remember c, which is the constant or the number by itself, is always the y-intercept. So we can look at the equation right here, or we can look at the graph to see the y-intercept of 0, -9. All right. The vertex actually be right here, the lowest point on the graph. That ordered pair is 0, -9. The axis of symmetry would be x equals 0. It's just, and if you note, the axis of symmetry is just the x value of the vertex. Axis of symmetry is x value of the vertex. And so if we draw a line here, I'm going to try and draw a dotted line. X equals 0. It cuts the graph equally in half. So it's always the x value of your vertex. And since this graph opens up, of course we will have a minimum. So this would be a minimum because the graph opens up. And if you notice, is a positive or negative? Well, we don't have a number in front, but we know we don't see a negative, so my a is positive 1. So we can see here that that graph opens up. So let's take a look at this real life situation here and analyze this graph using our knowledge of the key features. And after this, I have the last problem that I would like for you to try on your own. Alright, so it says Aaron shot a water bottle rocket from the ground. A graph of height over time is shown below. So question A asks, it says identify the x-intercepts. So the x-intercepts are here and here. So they would be 0, 0, and 0, 5. B, after how many seconds did the rocket hit the ground? That would be 5 seconds because the rocket started and then it went up and over and it hit the ground after 5 seconds. My x value is represented by the time there. C, identify the y-intercept. So the graph crosses the y-axis at 0, 0, again right here. If the graph would have started here as an example at 5, like if it would have done this, right, the y-intercept would have been 5. But since it started at the origin, my y-intercept is 0, 0. All right, part D, at what height did the rocket launch? It launched from the ground, so it launched at 0 meters. Estimate the vertex. So I'm on part E now. The vertex would be here, right? So it would be the highest point on the graph. It's going to be at about 2.5, 6.25. So again, it's just the estimation. All right. Is the vertex a maximum or a minimum? Well, that's the highest point on the graph. So that is a maximum. G, identify the axis of symmetry. Remember, the axis of symmetry is just the x value of your vertex, so x equals 2.5. And if you draw a line here, it crosses. I'm going to try to cross it at about 2.5. So this would be my axis of symmetry. All right. So even if you did not have the graph, you would know how to find the axis of symmetry if you had the vertex. It is just the x value of your vertex. In H, it says, after about how many seconds did the rocket reach its maximum height? And that is 2.5 seconds, because that's the highest point on the graph. So that's the maximum height of 6.25. And it took it 2.5 seconds to reach that maximum height. Alright, I would like for you to try this problem on your own. It says a graph of a bungee jumper's height above the ground over time is shown below for the first jump, down, and back. So try to answer these questions on your own. Go ahead and pause the video and try these problems on your own. Alright, so A, it says identify the y-intercept. It is 0, 190. Hope you got that correct. From what height does the bungee jumper make its first jump? Around 190. So the y-intercept, because it starts from here, right here. Identify the vertex, 3, 5. Right here. Is the vertex a maximum or minimum? It is a minimum. Identify the axis of symmetry, x equals 3. What is the lowest height the bungee jumper reaches? Around 5 feet. So we're looking at the y value of your vertex. When does the jumper reach the lowest height? After 3 seconds. Again, looking at that vertex here, or here. And why are there no zeros for this situation? So an added piece there. Well, if you think about bungee jumping, the bungee jumper should not hit the ground. That would be a horrible thing. And so that graph does not cross the x-axis, because the jumper leaps and he bounces back up, and so he does not hit the ground. Alright, so we've reached the end of our list, and I want to thank you for learning with me. Some related videos are solving quadratic equations, the quadratic formula, and solving quadratic equations using square roots. And so on those videos, you actually get to solve those equations and to see how to identify the solutions. And remember, it's where the graph crosses the x-axis or the x-intercepts. So if you haven't already, please like, comment, share, and subscribe. And once again, I want to thank you for learning with me.